So it's my great pleasure and honor to be here to share our story at the California State University Northridge. Since I'll just give you a few numbers before I share our story. I think CSUN, Cal State Northridge is one of the 23 campuses in the CSU system. We are the teaching intensive university, typically called the teaching university, not the R1 or R2 research university. And our regular teaching load is 12 units per semester. That means 4 courses per semester. It's not like R1 or R2 research university only teach like 1+1 or 1+2, right? So, and also our new faculty to be recruited at the CSU system. I mean, specifically for CSUN. I'm not aware other, the CSU system. Our startup package is only like 25K. And our resources are limited. But we have a large number of students. So how we can survive? And then the university just put us in the ocean, right? And with limited resources, how you're going to fly? So today I'm going to share these stories like how we did in the past. So first of all, I really appreciate the support and all the resources provided by, the NRP Nautilus, especially thanks for Larry and Thomas for this invitation and then to be presented here. So CSUN, we started this, the domain R&D back in the 2018. Initially, we got one grant from NASA, and then at that time, we just also from the DOE Sesame grant, and we started working on the AI machine learning to apply in the manufacturing domain. And then initially, we only got like $6,000 from Amazon for the credit, but we just use it within 2 months. And then we realized like how we're going to afford the expensive, the cost to move forward. And then at that time, I was introduced, by the GP from UC Irvine in the Cal IT Institute. And then we learned, they have a free, Nautilus wonderful platform that we can use. So start from there, and then our group, including myself and also Professor Han from the ECE department, he's also here today. And then we're working together and then presenting today as well. So our knowledge is, right now we are mainly focused on like knowledge graph, the based industrial AI, to apply the AI in the manufacturing domain. And this is the user is like shared by, Larry. And then this is probably we are on the top in the whole CSU system. I'm not sure whether maybe number 1, number 2 usage, to leverage the Nautilus GPU and the CPU resources. Like for in the past 6 months, our group has used like 14,000 GPUs, and then GPU hours, sorry, and then the 10 GPUs, and then the CPU is like 80 hours, CPU. So we have 2 namespace. One is Sesame as smart connected worker. Another one is SF Mega. And these are some of the projects has been, supported by the Nautilus. So, for example, we got the initial one is the Smart Connected Worker funded by DOE Sesame grant, and we partner with GP Li from UC Irvine, and also the ICAS, from UC San Diego for the as the one of the partners for that grant as well. And then we work on the energy disaggregation for the manufacturing plant, right? And then also the Professor Han from ECE department, he's leading the research for the medical images restorations through like the optical and the CT scanning. And then right now, most recently, we have partnered with the different like Autodesk, the GPL, NASA GPL, and also the National University of Singapore, because I was taking a sabbatical leave at National University of Singapore last spring. And then we also have the project with UW Madison on this like a multi-domain AI for the manufacturing. So These are some of the, the another fact sheet. We use a lot of the GPUs and then the CPUs, and also in the past they work really well for our like, the limited resources, the campus, and then we don't have the high performance computer, the center on campus until now, right? And then we did a lot of them, and then we have also used a lot of LLMs right now, and then to train the large language model and the Google, BERT as well, these in these areas. So these are some of the publications that has been, the supported, by these two domains. For example, for the first one, the SESME SCW, we used almost like 7,000 GPUs hours in the last 6 months. But if you go back to in the past few years, we use more as well. And then this all the publication we will work together. And then for the newer one, the SF MICA is multi-domain AI research, for the manufacturing, domain R&D. Right now, I think we have used like over 7,000 GPU hours in the past, the 6 months. Maybe this like publication for the R1, R2, the institute probably is pretty easy, but you cannot imagine how we, achieve these goals. And in the past, the few years in the CSU system, like with limited resources, and then the grants as well. So next, I'm going to deliver, some of these research projects, briefly, and then maybe we can go with the question. So these are the first projects was initially funded by the DOE SESME, and then we at that time, we started using the Nautilus, right, back in the 2018. So these are the 2-year projects, 2019, and then it's $2 million grant, and then we partnered, led by the UC Irvine, and then CSUN is a part of that, and also the SDSC, UCLA, General Mills, Honeywell, and the Aerospace Corporation, and Autology. And then we basically work on the smart kinetic worker, right, to leverage the new technology, including in Industrial 4.0, sensors, the machine learning, the deep learning algorithm, and then to improve the, the accuracy and the scalability and the accessibility, for the small and medium-sized manufacturing company, especially in the Southern California. They have a lot of, the companies located in the LA and the Orange County area, and then they don't have access, to this new technology at all, or even these resources like HPC resources or GPU, including GPU and CPU. But how we can provide the, the solutions, right, for these customers in the industry, and then they can still, develop the, solutions, and then to benefit the new technology, right? So this is the one like we use like a Nautilus a lot, to process a lot of data we collected from the manufacturing industry, like including Honeywell Aerospace, General Mills, and the small companies located in the LA and Orange County as well. So we use like a video processing, for the worker, action, for the skeleton detection, and for the data, the processing module as well. So this is a human-centered methodology, to integrate all the data we collected, including text, numerical data, images, videos, audios, all these multimodal data, right? And then these are the one of the case, like it's one of the lab located in the Northridge, and it's a advanced manufacturing, the lab, typical lab, and then we have all the like assembly line, robotic arm, and then the 3D printers, all this stuff, and then we're just trying to use this cost-effective device, right, and then to provide and then design the solutions for the small and the medium-sized company. And these are the, the algorithm that we used at that time, like including short-term, memory, the YOLO-based, the craft-based, for different purpose, right? And then here is one of the demo of our system. And it's user graph, it's a GUI, the graphic user interface we developed is web-based, and then the users, they can get access and see all the real-time monitoring of the manufacturing facility, also for the energy, the disaggregation and the monitoring as well. So I'm going to share more details about the energy later for another project funded by the California Energy Commission. So this is another use case project we did. We can create the digital model and the digital twin for the lab I just showed you. It's one of the advanced manufacturing lab. And then, we partner with one company. It's called Sim Insight. It's a small startup company, but their system is hyperscale. So they only have the step-by-step guidelines and the basic, training ability. But when we use them, for our use case, we realize we cannot, track your finger gesture and then to achieve the human-machine interaction, right? So in that case, we just use the machine learning, deep learning, the algorithm to apply them to. In this case, it's for one of the initial one, we just work on the FDM, the desktop scale 3D printer, and then we develop this, the small, the app, and then they'll be embedded into this company's existing platform. They help them a lot, and also achieve like whenever you press the panel, the buttons on the panel, and then you can identify which step are in, and then you can navigate the users, right, to have more interactions with the system. It's not only like education training, but it's more practical training for the users. And also after that, because one of my main research areas is metal 3D printing. As you may know, in the metal additive manufacturing, the machine is super expensive, and also training is also really expensive. Like we need to pay $5,000 every year, for the Autodesk engineer to come to campus into the maintenance and annual, the service. So what we did is we developed this training system to reduce the cost and to get rid of the human operation and the training. So we just use them also use a lot of the Nautilus, in the metal 3D printing operation, the training. And then we developed this system, and then a lot of the operations, the specific operation, which is collect a lot of images and do the labeling, and then train them on the Nautilus, the platform. So this is the one we did. And then this is just another one demo showing both the front end and the back end, how we integrate, and then operate the metal 3D printer in the virtual environment and also the physical side. So we tested, by I think over 20 users, especially for the first time user of the metal 3D printer, how the experience by using this system. We developed it based on the Microsoft, HoloLens 2, and then still use them a lot in the classroom, and then for teaching as well. So the students, they learn a lot, and then by using this, the system, because whenever you run the real metal 3D printing in the lab, the metal powder is really expensive, so every time they will cost like $2,000, to run one single print. So but this system, they save us a lot of money, and also the students have a lot of great, the experience. So in this case, you can do the identification and then do the object detection as well in the system. And then this is just to show you the front end. And then they can identify this valve. Since I'm running out of time, let's just go a little bit faster. Sorry. This is another project, it's continuous projects on the smart kinetic walker. And this was funded by the CEC, the California Energy Commission, to invest on the energy disaggregation, right? How you can use just 1 meter to tell, each machine's state. Right, because typically you have to use a meter, to monitor each machine in the past, right? But right now, if you have only 1 meter, how are you going to, get each machine state? So we collect all the data in the lab, and then use, the LSTM methodologies, and then to process this time series data we collected in the lab. Also, we use a lot of Nautilus, the GPUs and CPUs as well, in the research. So these are the, the architecture we use, and then we designed the two had. One is the machine state, another one is energy consumption. So it was really, successful, in that. So these are showing some of the examples and the results, how we compare with other, algorithms as well, based on this, the real time, the data collection and the, prediction that we did in the lab. And this is the one like Professor Han led, and also partnered with the Institute in Europe. He's especially working on the low dose, CT image, and then did a lot by using, the Nautilus a lot, because his data size is huge, and also consume a lot of the GPUs. And then because of the limited preliminary results that he collected and the work on the Nautilus, and then another really good news we want to share is like 2 weeks ago, we were notified by the NASA, and then the proposal we submitted, like efficient deep learning for the space computer, was funded by the NASA RIA, the program. So it's really, really super exciting, and then make it happen, and the success in this area. So they did help our professors in the CSU system, I think, a lot to achieve that. So this is the most recent the research work we specifically working on the manufacturing domain, how to leverage the machine learning and especially large language model, right, to build the knowledge system, how to extract the knowledge, right, and then to bridge the gap, right, between the knowledge, the extraction in the manufacturing. Because whenever you fire all the people, senior people left in the manufacturing domain industry, I think there are always the knowledge loss as a big loss for the company. So sometimes, like when we visited one company back in the San Fernando Valley in the LA city, and then there's one company, because during the pandemic, the one senior maintenance manager was early retired, and then that company, they just didn't notice the maintenance, like the dust cumulative, underneath the conveyor belt. And then 1 month later, after that manager, left, the whole, assembly line was down. And they invested almost 1 month to figure out, oh, that was because of that specific, the dust, the underneath this conveyor belt. So they have to, report that and then replace that specific roller. But they did do that. So they lost almost $1 million because of the downtime for 1 month. So that's really critical, for the manufacturing, the company. Also for our like metal 3D printing right now, we have to fully understand what's going on with a lot of, the porosity generation. That's a multi-domain, issue. They have like the powder issue, material science, and then the thermal issue. So right now we're using like X-ray images, thermal images, acoustic signals, and the visible light, camera to monitor the metal 3D printing for the laser powder bed fusion, system, for example. And then we're using this, lot, and so that's why you noticed on the slides number 2, we use a lot of the GPU hours, for the second namespace, we did. So this is some of the examples that we did, for the multi-domain, and then we use this Apache Tika, and also the ChatGPT API system a lot, to process all the different type of data we collected in the lab, including text, images including X-ray images, the thermal images, on the RGB image as well, and acoustic signals, and then to process them. So these are the basic one we use, large language model to process them as well. That's the we use Nautilus a lot, in the past 6 months. And then these are some of the results, preliminary results we got, and then already published one paper in the Journal of Intelligence Manufacturing, and then showing all these different results. This is some examples, like we use this pre-trained model, and then to control robotics arm. right, in the lab, and then how you can achieve different actions, right, in that. So these are some other, the results. We run these different models on the Nautilus system, right, to compare the performance like ChatGPT 3.5 for, the Palm 2 and then Llama 2 as well, and then to get all these different results, and then to see, which one is more efficient and effective, for our manufacturing domain, and then they can address the challenges in the manufacturing. I think that's it for my story. Thank you so much. Yeah.
Questions? I took a picture of your various projects, and I was going to show it to our faculty when they complain about the amount of teaching they have to do. So I'm pretty impressed. But
yeah, I think it's really hard, for us, especially the teaching intensive university, to conduct research with limited resources. So that's why I really appreciate, this platform, the NRP Nautilus, right? It did help us in the past, the 5 to 6 years. Otherwise, we cannot make it happen. Yeah, it's impossible.
all right.
Yeah. Thank you. Thank you so much.
Thank you. Let's thank the speaker.